Greetings, welcome to Learn and Burn Studios. In today's video, we're going to talk about how to prep a furnace for metal casting. So we're finally ready to move forward. We have our shells prepped, as seen in the previous video, all burned out, patched, and ready to go. So now we want to talk about how to prep the furnace and get it ready to fire up and melt some metal. So the bronze we're going to use is silicon bronze, 95% copper, 4% silica, sometimes it's referred to as Evidor, or 655 is the numerical designation for it, or referred to as nautical bronze, in the sense that that's typically where the silicon bronze is used traditionally before it was adapted by artisans like myself. Now the reason why we use it is between the copper and the adding of the silica, it makes it an extremely plastic material. And we think of metal as being hard and tenacious and everything, and so why am I using the term plastic? But the idea is that it's malleable but fluid. One of the challenges of working with copper directly is that it becomes work hardened. It starts off soft, but as you beat it, you move it around, shape it, it'll get rigid, and then you have to anneal it to soften it again. And so you wind up doing this kind of back and forth game to work with just copper straight out. But by adding the silica to it, maintains its flexibility and malleability as you work with it as a metal. For us as casters, it flows extremely well, it likes to be welded, and then ultimately it chases well, it takes a patina extremely well, and partly that's because of the higher copper content. And so it becomes this really kind of choice material for art casters to use. As far as melting the metal, we're going to use this big ceramic container. It's referred to as a crucible. What we're using today is a number 40. So this crucible will hold 40 pounds of aluminum, but for bronze, it's 3 times that number. So about 120 pounds of metal is what we're capable of melting in this crucible. The crucible itself is composed of silica carbide that handles extreme heats, upwards of 3,000 degrees. And then ultimately it's infused with glass. And where that benefits us is that as we come up to our molten temperatures, the glass sweats out of the crucible and onto the surface, and all the impurities in the metal, debris, dust, silicas, whatever, and so on, that will stick to the glass, and that's ultimately what we'll scrape off as the dross. And so it's a way of actually kind of cleaning the metal. Also, the glass keeps it, acts as a release, and keeps the inside of the crucible relatively clean in between pores. Okay, so now looking into the furnace as we get ready to load the crucible, I just wanted to make note of the design at the bottom of my furnace. I do have a hole, emergency hole, so if any metal gets spilt or God forbid the crucible breaks and I wind up with instead of winding up with a big solid slab of metal in the bottom of my furnace, which essentially will destroy the furnace, it ultimately is a drain hole. When I put the plinth in, the base that the crucible is going to sit on, it potentially just plugs up that hole. So I created these troughs when I was making the base of the furnace, which will allow it to extend. So as I put this in, you can see that the troughs extend just out beyond the size of this plinth. So it creates some drain holes for things to redirect in out of the furnace. Now, like I said, this is silica carbide, and you can see this has been fired once and annealed, but you can see how the glass is already kind of pulled out of it. If I stick the crucible on top of this, it will literally fuse the two together. So I need to create a barrier in between the two. Now, typically, you can use a couple different things. You can use raw graphite as a release, but you can also use pieces of cardboard in between the two to form a layer of carbon. To hedge my bets, I should have done this first, but I'm actually just going to put down a little bit. Keep the plinth from gluing itself to the bottom of the furnace. And then ultimately I do like putting down a piece of cardboard. Also, when we start up the furnace after a pot of metal, we'll put down dip a piece of cardboard into water so it doesn't just ignite into the hot furnace, but we'll go ahead and put that down again to create kind of a fresh layer of carbon between the crucible and the plinth. So with that said, we'll go ahead and stick the crucible in. roughly center it out. Here's my lip. So I'm going to make sure my pouring pit's facing that direction. So I want to have that pointing in the right direction. Okay, now that we have the crucible in place, we're ready to start loading our bronze into it. Now, like I said, it's a good idea to weigh out, have your wax weights, have an idea of what you're going to pour for each pot of metal. Just like we talked about in the wax videos, typically for every pound of wax, that translates to 10 pounds of metal. Do the math with specific gravity of the metals and what that, it comes out closer to 8 pounds, but it's easier to round up to the 10 pounds, and that way it also accommodates for any kind of slop or mispours, so you make sure you have enough metal for your specific pattern and sprue system. Weighing one of the skulls that is still in its wax form comes out to about a pound and a quarter. So times 10, roughly about 12 and a half pounds of metal. In this case, the cup is actually just styrofoam and wax, so this is not a true representation of how much weight we're going to need for the cup. So we're going to add about 5 pounds for that. So we'll need roughly 16, 17 pounds of metal per skull. Now we will add a little extra metal, maybe an extra 10 pounds for slop on the off chance we get a leak. Ideally, get a couple of ingots in there. These are going to be your largest masses and will take the longest to heat up and melt. And as we're putting things in, we want to be mindful of the fact that the metal is going to expand as we heat it up. So however we put metal in here, a combination of the ingots, and these are ingots that were actually left over from my last metal that I poured in, was left over from my last pour, as well as a commercial ingot or two. Now for me, and the way my furnace works, it's a little tight with these longer ingots. So a lot of times, most of these I'll actually feed in through the top hole. And then when I'm using, casting my additional ingots, or pour cups, what I want to do is, I don't want to just wedge things in here, super tightly for that expansion reason. So ideally what I'm going to do is either set them down wide end first, or even kind of horizontally. It's really not a matter of actually getting as much metal in here as possible. Put in here whatever's comfortable, and everything has some space to kind of move around. And then as it melts and generates more space, then you can feed in more additional material. It is worthwhile to go ahead if you have to clean these things up and knock off a little bit more of this material. But at the same time, you can get away with it. That material will float to the top with the rest of the dross that can be skimmed away. Okay. So there we go. We have the furnace set up and loaded. We've talked about some basic safety, and we're ready to go. So in the next video, we're going to gear up and actually light the furnace and pour some bronze. And then, and as always, if you're digging the content, subscribe so you get some notifications on when I put out the next video. But more importantly, if you can, leave some comments down below and ask questions. Let me know what you're dealing with in your situation for your foundry. What are some of the things that you've come across that are jamming you up? And let's see if we can work through some of those problems. And until the next video, be creative and be safe.